Hey everybody! In this video I wanted to break down my first Unreal Metasounds project. This is a modular music system that allows the player to mix and match different stems via a widget. The goal of this project was to learn Unreal Engine, Metasounds, and also to try to build a completely modular music system while using all of the techniques I've learned over the past few months. So everything begins with a Metasound patch that I called MSP Stem Group. This patch handles a set of wave players routed through a multi-channel mixer. Each mixer's gain is exposed as a graph variable, allowing us to control levels dynamically. The wave asset for each player is also promoted to a graph input, letting us load stems in the containing Metasound. Each MSP stem group is responsible for one musical category, like drums, bass, or lead, and contains several stem variations. To control which stem is active at any time, I've created a graph input for each wave player. These are labeled set 0, set 1, set 2, etc. When one of these inputs is triggered, it does the following. It sets a corresponding float value from 0 to 1. That value passes through an interp node, which smooths the transition for a fade-in effect. That float is then passed to the corresponding mixer input variable. That input also triggers a trigger any node for all other stems that resets their float value to 0, so they are muted while this one is set to 1. This part was the messiest, and I believe there is a better way of doing this using an array of wave assets that would also be more optimized, which is something I plan to tackle in the future. Next, I placed multiple MSP stem group patches into a higher level Metasound that I called MS Stem Player, one for each musical category. Then I assign each wave asset, which I've named by category followed by a number sequence, as well as promote all of the trigger inputs to the graph so I can trigger individual stems externally. A trigger player's input is also exposed to start playback across all groups at once. So when on-play is triggered in the stem player, it routes to the harmonics music transport system. This provides tempo and timing data, which then drives a metronome MIDI clock generator. From here, we use a subdivision trigger node to generate 3 timing pulses. One every beat, one at the top of each bar, and one at the end of a 32-bar section. These are promoted to graph outputs for external use. Then, in an actor blueprint called BP Music Manager, I have included MS Stem Player as a component. This music manager will be the top-level control for all of the music functionality, and will be what other objects will interact with. On begin play, we get a reference to this component and use the execute trigger parameter node to initialize all stems to their set 0 state, ensuring everything is preloaded without triggering fades. I also set up to watch the output triggers from MS Stem Player. Each quantized event, beat, bar, or section fires a custom event in the blueprint. To be able to communicate with the music manager from other blueprints, I've implemented a blueprint interface. I won't go into detail about setting that up, but these are great for keeping your functionality modular and decoupled. This blueprint interface has 2 functions defined: start music and trigger stem, which takes an input of type name, which is later used to swap stems. To start the music, any other actor can call the start music function, and any functionality we have from this event in the music manager will be fired off. I've created this in an actor I called BP Start Button, which includes both a button mesh and a collision box. From the on-play event, I enable player input, use an enhanced input action to handle button presses, and open and close a gate based on player proximity via the collision box. So when the player presses the button, it will play a sound effect, which is a click with a very long riser afterwards. Then it triggers a button press animation. Then I get a reference to my music manager and bind a custom event to the bar change output. And then at the top of the bar, I kill the riser sound and call start music via the blueprint interface. Just for fun, we can change the bar event we're watching to happen every 4 bars, And now depending on where in the 4-bar phrase the player presses the button, we can hear this go on for a bit longer. Back in the Music Manager blueprint, the music start event fires off an execute trigger parameter to trigger all of the players to start, and then sets a music is playing bool to true. This variable is used to detect whether to re-trigger playback every 32 bars, syncing stem restarts to the top of the section. To allow the player to change stems, I use a widget. Each row shows a category. Each row also contains buttons equal to the number of stem options for that category. Each button's on-clicked event calls trigger stem through the interface, passing the corresponding name, like set drum 0, set bass 1, etc. These names all have to exactly match the corresponding trigger, as we'll use this name to just feed the in-name input for the execute trigger parameter node back in the Music Manager blueprint. Finally, in the player's character blueprint, a widget interaction component allows the player to point and click buttons in the world to change stems in real time. So that's pretty much it from a bird's eye view. Depending on where you're watching this, I'm going to have a bunch of video links included in the description. These are all in-depth breakdowns of a lot of the things that I touched on today without really diving into. If you're watching this looking to learn, I highly suggest checking these out, as well as looking at some of the other videos on these channels. They all have a lot of amazing content on specifically audio and Unreal, so highly suggest them if you're looking to learn that. Thanks for watching, and see you next time. Bye.
I'm